Look around you. Everything has color. The blue sky, green grass, your red shirt. But here's the shocking truth. Color doesn't exist outside your brain. There's no blue in the sky, no red in an apple. Color is your brain's interpretation of electromagnetic waves. It's a beautiful illusion painted by your mind. Let's dive into the science of how we see the rainbow. Color starts with light. Light is an electromagnetic wave rippling through space like waves in the ocean. But these waves come in different sizes called wavelengths. Tiny wavelengths look violet. Medium ones look green. Long ones look red. Your eyes detect these different wavelengths and your brain labels them as colors. Color is wavelength translated. The electromagnetic spectrum is enormous. It includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. But humans can only see a tiny sliver called visible light, from about 380 to 740 nanometers. That's it. We're only seeing a fraction of 1% of all light. We're basically blind to most of reality. Your eye is an incredible biological camera. Light enters through the cornea, passes through the pupil, and gets focused by the lens onto the retina at the back. The retina is covered in light-sensitive cells that convert photons into electrical signals. These signals zip down the optic nerve to your brain. You're not seeing with your eyes, you're seeing with your brain. Your retina has two types of light detectors, rods and cones. Rods detect dim light but can't see color. They're your night vision. Cones detect bright light and color. You have about 6 to 7 million cones and 120 million rods. That's why at night, everything looks gray. Your cones need bright light to work. Color literally disappears in the dark. Here's where it gets cool. You have 3 types of cones, each sensitive to different wavelengths. S cones detect short wavelengths, blue. M cones detect medium wavelengths, green. L cones detect long wavelengths, red. Your brain combines signals from these 3 types to create all the colors you see. 3 simple sensors create millions of colors. This 3-cone system is why screens use RGB, red, green, blue. By mixing these 3 colors at different intensities, your TV can create over 16 million distinct colors. It's literally hacking your biology. The screen isn't actually making yellow. It's tricking your cones into thinking they see yellow. Every image you've ever seen on a screen is just red, green, and blue dots. About 8% of men and 0.5% of women are colorblind. Most commonly, they're missing or have defective M cones or L cones. This makes red and green look similar or gray. Some people are completely colorblind, seeing only in shades of gray. A few rare individuals have 4 types of cones and can see colors the rest of us can't imagine. The sky isn't actually blue. Here's what happens. Sunlight enters the atmosphere as white light, containing all colors. Air molecules scatter short blue wavelengths more than long red wavelengths. This scattered blue light hits your eyes from all directions. The sky appears blue because you're seeing scattered light. At sunset, light travels through more atmosphere, scattering away blues and leaving reds. Physics makes the pretty. A red apple isn't actually red. The apple's surface absorbs all wavelengths except red, which it reflects. Your eye catches that reflected red light, and your brain says apple is red. But in darkness, the apple has no color because there's no light to reflect. Color is a partnership between light, objects, and your brain. Nothing has inherent color. Plot twist. White and black aren't actually colors. White is all wavelengths combined, hitting your eyes at once. Black is the absence of light, no wavelengths at all. White is everything. Black is nothing. That's why you can't make white by mixing paint. You just get brown. But mixing colored lights makes white. Pigments subtract, lights add. There are colors that exist, but you'll never see. Infrared and ultraviolet are beyond your visible range. But there are also impossible colors, like reddish green or yellowish blue. Your brain can't process them because they'd require opposite cone signals simultaneously. Some people have seen them using optical tricks, and they report it's utterly indescribable. Colors that break your brain. Many animals see colors we can't. Birds and bees have 4 types of cones, including ultraviolet detection. Flowers have patterns in UV that we're completely blind to. Mantis shrimp have 16 types of color receptors. Some snakes see infrared heat. Dogs only have 2 cone types, so they see fewer colors than us. Every species sees a different rainbow. Your brain is constantly adjusting colors. An apple looks red whether you're indoors, outdoors, at sunset, or under fluorescent lights, even though the actual wavelengths hitting your eye are completely different. Your brain compensates for lighting conditions automatically. This is color constancy, and it's why that dress broke the internet. Everyone's brain was calibrating differently. Stare at a red square for 30 seconds, then look at a white wall. You'll see a cyan square. Your red cones get tired from overstimulation. When you look away, the green and blue cones dominate, creating cyan. This is called an afterimage. Your eyes adapt to whatever they're seeing. Stare at anything long enough, and you'll see its opposite color. Pink is a lie. There's no pink wavelength in the spectrum. Pink is what your brain creates when red light and blue light hit your eyes without green in between. It's a color your brain invented to fill a gap. Magenta is the same deal. They're extraspectral colors existing only in your mind. Some colors are more imaginary than others. Different cultures perceive color differently. Ancient Greeks had no word for blue. Some languages have only 3 color terms. The Himba people in Namibia can distinguish dozens of greens we'd call identical, but struggle with our blue-green distinction. Language shapes perception. What you can name, you can see more clearly. Color is partly cultural. Rainbows are optical illusions, too. They're not physical objects. They're patterns of light. When sunlight enters a water droplet, it bends, reflects inside, and bends again as it exits. Different wavelengths bend different amounts, separating into colors. Every person sees their own unique rainbow based on their position. Move, and the rainbow moves. It exists only for you. Not all screens show color the same way. Computer monitors use sRGB, covering about 35% of colors humans can see. Professional displays use wider color spaces like Adobe RGB or DCI P3. High-end TVs now do 90% of human vision. But some colors we can see still can't be displayed on any screen. Technology is catching up to biology, slowly. Colors trigger real psychological and physiological responses. Red increases heart rate and creates urgency. Blue lowers blood pressure and promotes calm. Yellow boosts mood and energy. Pink can even reduce aggression. Some prisons paint cells pink. These effects are partly biological, partly learned. Color is powerful, influencing emotion without you realizing it. Color is one of evolution's greatest tricks. It helps us find ripe fruit, identify predators, and communicate emotion. But it's entirely a construction of your mind. The universe is full of invisible wavelengths, and you're seeing a narrow, colorized version translated by your brain. Every color you've ever seen is a hallucination. But what a beautiful hallucination it is. Subscribe to see more invisible truths.